Oh no. Hold on. Apologies. I should have tested my stuff. I'm assuming everybody can hear me. Sometimes my camera does this. Hold on just a second. All right, let's try this again. Let there be me. All right. Hold on. All right, good afternoon, everybody. All right, as you can tell, this is a very last minute stream. Like, I decided to do this stream, and I am super unkempt even. Oh my gosh, I needed to shave and stuff today. Ugh, sorry about that. But this was a very last minute stream. I decided to do this about 30 minutes ago. I went to the gas station to grab myself a drink really quick. So today we are drinking, it's 2/3 Diet Pepsi, 1/3. Hold on, let me check. I'm just making sure that everything is going all right. Okay. 2/3 Diet Pepsi, 1/3 wild cherry Pepsi. Is that right? Yeah. So I like to mix up my combos every now and then. But anyway, so today the inspiration, like every once in a while I'll have these like light bulb kind of moments, or at least they feel like a light bulb moment kind of for me. And it happened to me about like an hour ago as I was preparing content for another forthcoming stream. So in that forthcoming stream, we'll be focused on MCP servers using a database backend, just to kind of demonstrate how you can create your own and serve your own MCP server. So that's still forthcoming. But then like the thing that I was thinking about was like, so typically like whenever I used to prepare a stream like 2 or 3 years ago, or well, probably a little bit longer than that because of the generative AI revolution, it was that like it would take me days or hours or days to actually research a topic and be able to prepare on it. And so as I'm preparing for this next MCP one, using a mix of ChatGPT and GitHub Copilot, like I was able to get like 75% of the way in 30 minutes. It was insane. And so I sat there and thinking like, why is it that what is the gap between a new person, somebody who's never been in like a software developer or a software engineer kind of role, and somebody who's more seasoned? Like, what is the gap that is preventing people getting there? Especially now that we have these coding tools. Why is it that even though we have these coding tools, there are some people who are really good at like using these coding tools to like actually build stuff on their own with like vibe coding. So, but like there's a lot of people out there. It's just like, well, it's producing this thing, but I'm not really sure like how all these pieces kind of fit together. And then it hit me. It's systems architecture. It's this understanding. If you have a high level understanding of what systems architecture is and how all these different components play a role with one another at a higher level, then you can really start to design systems and such. And then like the GitHub Copilots or the Claude codes or these other coding tools, that's when they come in to help you with like that lower level kind of thing. And that's and the reason I kind of bring this up is so having that intuitive high level understanding, you don't the way I don't want to say that you'll never need to learn how to code. Like I don't know if I'll ever envision that future, but it lessens the need for expertise in coding, meaning that like if I have a high level understanding of Python and then and I need to be able to like build a fully blown architectural system, then I don't need to have like an in-depth knowledge of Python because the coding assistant will help me out with that. So with that, this is going to be an extremely high level introduction. When I mean, it's just for context. So I actually don't have any sort of formalized degree in computer science nor in software like engineering or anything like that. My degrees are in business, business administration, and organizational leadership. And I upskilled myself through a bunch of online programs like Udacity, Udemy, etc. And that was like in 2018, 2019. And then now have been formally operating as a professional machine learning engineer for the last 5 years. So I'm actually going to go ahead and share my screen. And as I share my screen, I'm probably going to have the same camera thing. So hold on just a second. Yep. So you could probably still hear me, but you probably can't see me. Let me fix that really quick. I don't know why my webcam does that sometimes. All right, now you should be able to see me all right. Let me check on the screen down there. I got my other screen. and then now have been formally okay, whatever. So what I want to highlight here is I actually did write a blog post on like a simple mental model for designing any IT solution, and you could and the thing I want to highlight in here is that the date here, the date here is actually before I even stepped formally into a professional machine learning engineer role. What it was is as I was going with my learning, and there was actually, like I said, I use Udacity and other programs like Udemy and such. There was actually not like a singular systems architecture class that I took. And the reason that I highlight that is just like, so in undergraduate programs and such, I don't know how that's taught or if it's taught, like, or if people tend to focus more so on coding. But I had this aha moment myself around this time in 2019 of like, you can really kind of think about systems architecture and computers extremely simply. Now, like obviously, you can delve deep onto every single thing we're going to talk about today, and I'm that's going to be something I'm going to avoid. I want to keep this as simple as possible and focus on the main points here. All right, so I'm going to just move on to some graphics here that I actually created for the blog post itself. So the way I view it is when you think about like any sort of interaction that you do with a computational device, it's going to involve one of these three activities. So let's step back and like, because I'm going to try to be, again, as simple as possible. What do I mean by computational device? That could be really anything almost anything that has a screen, to be honest. Now, like, so typically you would think like a laptop or a desktop computer. Those are definitely computational devices. But I also want you to think about things like your iPhone, your Apple Watch, your Apple TV, your Roku, your smart TV. Those are all computational devices. So in the context of like an Apple TV or a smart TV, those are computational devices in the sense that it is downloading information from the internet. So the information in this context would be a video from Netflix or Disney Plus or something like that, and it is just displaying that on your screen there on the TV. So let's stick with the Netflix example here. Actually, you know what? This is going to be hilarious if this. Oh my gosh. Wow, I am extremely consistent. I actually did not look. So like I said, last minute thing. Like I completely forgot that I did this until now. I promise I did not look at this before. But what I wanted to highlight here anyway is like imagine that like there's a number of different devices here off here on the right that can actually stream Netflix. So smartphone. Smart television, etc. And you could see like, so maybe I don't want to use this picture because now I'm confused by what I was intending with this picture. But the idea here is, well, let me go back to this other view here, is so storing information. Think about Netflix themselves. So Netflix themselves, they are going to have all the movies and all their shows on their databases. And we'll talk more about databases and such in a little bit. So they're all stored on there. So, but like let's say I fire up Disney Plus and I want to watch the newest Marvel movie. So now what's going to happen is, there's a kind of a two-way street here. So when you click that button on your remote to like actually select the movie you want to watch, it's processing that information. So it's saying, okay, this person clicked the button on the remote. They have the intention of wanting to watch the newest Star Wars movie. And so, did I say, okay, I'm going to say the wrong examples multiple times because I'm pretty sure I just said Marvel, then Star Wars. So whatever. You want to watch the newest movie. And so obviously your TV itself doesn't have the movie on it. Like it has to get it from the internet. And so what we are going to do is we're going to say, okay, let's take that request of saying, yeah, I want to watch the newest I'm intentionally going to screw things up now. The newest Pixar movie. And the way that's going to work is it's going to go over to Netflix. So now we are taking the information that we want and we are moving it over to Netflix saying, hey, or Disney Plus. Again, I'm going to be so bad with my examples here. We're moving that information over to Disney Plus and saying, hey, we want to watch this specific movie. And then what Netflix or Disney Plus is going to do is they're going to say, okay, understand, assuming you have a subscription, we're going to load this up from whatever database they have, and then they're going to move this back to you, to your TV or your other smart devices or your iPhone or whatever, and your TV is going to receive that file and then probably process it again to make it work with your TV, and then display it to you, both audio and video. And this, so I use that very simple example, but this is really true for pretty much everything. So if you think about like ChatGPT, for example, so ChatGPT, you're going to input your information onto your device, and like your iPhone's going to process that, understand what you want to do, and then they're going to send that information over to OpenAI, ChatGPT, over some sort of networked line, and we'll talk about networked lines here in a little bit, but we're just moving the information. And then if you have like history and stuff in ChatGPT, so OpenAI is storing that information. So you might want to refer to a former, like let's say you already have an ongoing conversation, you just want to continue the conversation. So they are going to load that information from their databases, and then they are going to move this back to you, or they're going to, well, on their side, they're also going to do processing, so they're going to take your input prompt and they're going to pass it through their model and give you an output, and then they're going to move it back to you. And that's why I say, like, this is the bare bones minimal. This is, so like I said, I developed this mental model for myself in 2019. This is still very much how I think about things these days. And in fact, I've got other graphics. I think the formal blog post is out on LinkedIn, or I'm sorry, not LinkedIn, Medium somewhere, or maybe it's LinkedIn. I don't recall. But yeah, so that is so starting from that, now let's start to move into some more computery kind of aspects. And with that, I just have a blank draw IO diagram here. We're going to diagram things out live. So I'm going to say, let's get a computer out here. All right, let's stick this computer right here. Okay, so we have a computer here. And so what I want to highlight about your computer here is, you might be wondering, what is the difference between a computer and a server? All right, I'm just going to call this my server. All right, and the fundamental answer is not much. Not much in terms of, like, there's not actually, like, the way that we're not going to go deep on how computers work necessarily, but the way to think about a server is very much the way you to think about a computer. So again, coming back to my graphic here, we're storing information, we're moving information, we're processing information. So your computer, you already kind of know how to do that. With a server, it's just doing that at a much more massive scale. So you can imagine, like, let's say this is Netflix over here, and this is one of Netflix's servers. So this would just basically like be a big honking computer, very similar to kind of this, but it's going to be more complex. Now, again, if I have any true systems architects watching this, you're probably going to like cringe at some of the way I'm describing this, but I am trying to make this as intuitive as possible, because and again, you can spend all day learning about servers and everything else, and I'm going to attempt to avoid that here. But let's say, all right, so we got the computer over here, we got a server over here, and so both of these devices, I'm going to fixate on the server specifically. So the server here, it really can manifest as some different kinds of things. So maybe this is the server that contains it contains like all the ways you'd interact with Netflix. I don't know, like, or Netflix profile information. We'll say that. And maybe you have a second server over here, and it I don't know why I didn't try to copy paste there. There we go. All right, and then so we got another server over here, and it's doing I don't know, something else. So the thing to keep in mind here is the way that these all talk to each other. And I'm gonna make this a lot smaller now. I'm gonna try, like, this is gonna be hard to do on the fly here, but we're gonna make do. We're gonna try to make do. All right. So then, and the reason I like dry IO is it has like these smart connector things. So, all right, and I'm gonna make this a double-ended arrow. All right. So you can see here, what I'm representing by this arrow here is the movement of information. So this is, again, if in the Netflix example, this could be, well, in fact, I'll even throw, is there a TV icon in here? Maybe. Here, I'm going to move this over. Well, that's TV. Okay, Draw.io does not like TVs. All right, let me try smartphone. Surely there's a smartphone in here. Yeah. Okay, that's oddly specific, but okay. So they're also interacting, trying to watch a movie or the latest hit show or whatever. And so what these arrows represent here, we would refer to as networking, and networking transparently is something that is very much not my skill set. Like that is one, but it's an extremely important skill set. And so actually what I should highlight here is, so you can network from like your server to like your customer devices, but then you can also, and the reason I'm moving these arrows off is again, I'm drawing this picture on the fly, so forgive my artistry right now. I don't want to fill. I want to make this. So what this might what I'm trying to represent over here with this dotted arrow is, so you might actually whenever these devices are interacting with these servers, you might be thinking, okay, well, how do I protect against bad actors, or how do I protect against hackers and stuff? And so this is where your other devices, I'm going to move this to the back, your other devices or your other servers within here are also going to be linked together, more specifically networked together. So that way, if like let's say this is the I'm actually going to put names on here, the profile server. So if this is the profile server, I'm going to make this bigger because we're going to add stuff into it in a little bit. And this is the watch history server. Then these things can talk to one another. And then you can actually set up different things like networking rules between these things on like how these things should be talking to each other. And we call that that idea of minimizing interactions between devices and servers as least privilege. And the reason that we are concerned with that is because, again, if you have a bad actor, like let's say we have, and we're going to call this, I don't know what this is right here, but I'm going to call him Mr. Bad Actor. Mr. Bad Actor. Oh, that's not coming out well. So like, let's say we have Mr. Bad Actor over here, and he's trying to get into like our networking thing, and he wants to hack our servers over here. Well, then if we have our networking rules set up, then I'm hoping that, is there like a line with a strike through here? I'll build it on my own. We can do that pretty easily. So we're gonna say no, that's not gonna happen. So if you have your networking rules set up appropriately, I'm gonna try to make this good enough. So if you have your networking rules set up appropriately, then you can stop these bad actors. And this is what our cybersecurity friends were all about. Like, and again, cybersecurity is not my strong suit, but it's important to understand, again, at a high level, what are the different various components of systems architecture, and you'll quickly start to see, like, I don't have to have a deep understanding of these things. That's what my other friends are for. I'm a machine learning engineer, but having this high level understanding, then I can get a true maximum benefit of generative AI because, let's go ahead and jump into that. So you might be wondering, how do these servers know what to do? Like what is the blueprint or instructions of how they know what to do? And that's where the coding aspect comes in. So you can imagine that in this server, it may be running, it could be running Python code, it could be running JavaScript code, etc. Same thing over here. And that's the stuff that like GitHub Copilot or other AI coding assistants are really good at helping you out with. It's just the struggle is if you don't have this high level understanding, then it's kind of hard to make sense of, oh, what am I actually doing? What's this code actually doing? So the other thing I'm neglecting to mention here, and I just recalled as I talked, so servers in and of themselves can have memory, like memory in the sense of like storage. So imagine your smartphone or your computer, like you can save stuff to that local device, whether that be photos or notes or whatever. No problem. But there may be but with like servers and stuff, that technically speaking they can do that, but that is not best suited for something like this. Instead, you would want to have an adjoining, and I guess, well, never mind. You would want to have this backend system that we call a storage device that we call a database. And surely we got databases here. Okay, so in this case, you'll see that this is going to be our profile database, and then this is going to be our not our profile database. It's going to be our watch history database. Watch. Oh, I realized my face is in the way. Sorry about that. History database. Okay. And I'm going to make this a double-ended arrow. I'm going to make this one a double-ended arrow as well. And I apologize if you're wondering what's all the stomping upstairs. Again, because I decided to do this live stream last minute, I didn't tell my daughters or anything that they couldn't do what they were already doing, so that's what's going on up there. They're stomping above my head, so they're having fun, so I'm not going to spoil their fun. So anyway, so you have these databases that are going on behind here. So again, let's come back to our picture. So with behind the scenes for something like a Netflix or a Disney Plus database or server, they may be storing information about your watch history or your profile information, and that's what our databases represent. Our databases here, and then in order to interact with those databases, you would have these various servers, and they don't necessarily have to be various servers. You could have one giant server, and then we would call that like a monolithic kind of server. More often, we actually have these things are broken down into as small components as possible, and you might refer to those as microservices. And so like this, and in the AWS terminology, so you could have something that's more beefy. So that would be something like an EC2 instance, or like I was talking about with like a microservice kind of architecture, then these may represent AWS Lambda functions. Okay, so that's that. And now the reason I put this, again, I put this dotted line around this whole thing is, again, we want to protect against bad actors, and we want to make sure that whenever it comes to, again, this idea of moving information, that it's not being moved into the hands of somebody that should not have it. So we're okay if our smartphone customers or our computer customers are watching our content, but Mr. Bad Actor who's trying to steal everybody's information, we don't want them interacting with us. No, thank you. So we have like what we need to be extremely cognizant about with systems architecture is all the networking that goes around this. And again, the networking in and of itself is very much a big skill set, and so is cybersecurity. So I don't want to downplay those skill sets by any means. They're extremely important. We're just going to keep things at a high level, especially for people like me as a machine learning engineer. It's important for me to understand this. And the nice thing about these cloud compute companies is that like they're actually pretty good at giving. Well, they do a lot of like what they call like managed instance kind of stuff, and what what like AWS means by that, for example, is like with so there you may have seen a previous live stream before where I've talked about AWS SageMaker, and AWS SageMaker is their service, their managed service for machine learning stuff specifically. And so the nice thing about that is it's very much a managed service in the sense that like I am focused on the code that actually builds or deploys the machine learning model, but I don't necessarily have to worry as much about like all the networking stuff around it. Now, obviously, if you're a big company, you are going to have some extra stuff there. And, I'll just say like within, well, I don't think this is any secret. So within State Farm, obviously, we have a fully dedicated cybersecurity department who and then other like cloud computing departments that are very, very dedicated and very much appreciated for sure. If you're watching, thank you. So they'll apply their own specific rules and such, but it's important to recognize that is a very important thing to always keep in mind. So I guess if I were to summarize that is always be checking who are you giving the information to, or where are you getting the information from. So if you leave with one thing here only, it's just remember the idea of least principle, the concept of least principle, and that is again this idea that like you should only give or have access to things that you need to do to get your job done. And that could be internally within a company. So if I'm working on this profile server and if I don't need access to that watch history server for any of my part of my job, I should not have that access. And then even on the customer side, even if I'm not Mr. Bad Actor over here, if I'm a customer and my subscription is lapsed and I stop paying for my monthly subscription, I should also be blocked. Because that would be a violation. Well, I don't know. Maybe I'm stretching a little bit with that violation of least principle there. But Yeah, so that's important. But then we could like so I guess that's again this was kind of a last minute kind of stream here. That's really it. Like I'm trying to think at a high level, like what else to consider. Of course, we could talk about like, well, how do you expose out the server out of your network in a safe way? Well, and then that's when we might talk about things like how you expose APIs through like AWS API Gateway, but that's starting to get a little more low level. Like I just wanted to keep things at a super high level here. I'm trying to think of what else I want to share. And I am taking comments on LinkedIn specifically. I don't have my YouTube set up right now. Yeah, let me just glance back here at my other diagram. Yeah, so there, yeah. Okay, I don't know if I want to talk about that, just because I don't recall what I was necessarily going for there. But yeah, now this is my super high level introduction, and this is how the mental model I use for thinking about these sorts of things. That is not to say I hope nobody feels necessarily like they're walking away as an expert in systems architecture. That was not the intention of this stream. Definitely not. The idea is just to think to build this mental framework of when I'm building different things, how do I need to think about it? Actually, let me go into one more specific example because people might be a little bit curious about this. So let's say I'm building a website and you're wondering, how should I be thinking about building my website? What would actually happen here, and I'm going to keep all these boxes the same because, again, the general concepts are the same. Think about the website interface. What that is basically doing is it's loading your web page from your server, and maybe you may have some sort of database. Again, I'm oversimplifying everything here, but like what you might be wondering then is, how do I actually serve out my web page appropriately? And you have to think about it. What is your actual goal here? Because your goal here could be, I'm just interested in displaying content, like in a very static kind of way. And so like think about if you were to build your own personal website and it was just had like resume information about yourself, there's not really anything to interact with aside from viewing the content. In that case, you could get by with like a static kind of server. And this is actually an offering from AWS that I'm interested in looking at for building my own kind of resume like website. Is you can build a static website simply by hosting HTML files within an S3 bucket. So S3 bucket, again, think of it as another storage place. It's a object store on AWS. And so in that case, like that works great for that. But imagine that I am building a customer shopping website, like an Amazon. In that case, you would have to both have the website there, but you would also have to have some sort of computer or server behind that website that is helping to dynamically refresh the content of the page per the user's interaction. What do I mean by that? So imagine if I'm on Amazon and I go and I look for, I'm buying some book, whatever. I'm buying anything. When I click the button to add that to the cart, there needs to be that dynamic thing that says, okay, you've added this to your cart. And so then when I go to the next website, or I'm sorry, when I go to like shop for another item or just any other item on Amazon, you would still see it in the corner up there that says, yep, I have added this to the cart. Now, in that case, using that AWS static S3 thing that I was talking about, that's not designed for that kind of thing. That's going to take something a little bit more. But the ideas are very similar. You're going to have a server of some sort, and you might be wondering, well, what is serverless? Because you might be hearing this idea of serverless. There's a lot of funny analogies out there, but I can't remember any of them off the top of my head. But the idea of serverless is basically like there still is a server. Like that there's definitely a server. It's just that the customer themselves, they don't need to configure or worry about anything about the server itself. They just worry about like the behavior of your code. So like AWS Lambda functions, for example, those are considered serverless. And the reason that AWS is able to get by with that is because generally speaking, the Lambda function is pretty lightweight. It's designed for like like very quick little interaction. So it's something stuff that's very compute light, if you will. So something that would be compute heavy would be the generative AI models. The generative AI models are to like run an actual chat GPT is extremely compute heavy. But if you're just wanting to, I don't know, load or interact with an API that loads like the current temperature outside, that's very compute light. And so it's server. So to the customer, because they're not having to worry about this server here, then it's almost like it's serverless, and that's why we call it serverless. So, all right, I think I'm good. I think I covered everything that I wanted to today. So again, this was an extremely last minute stream, yeah, I just wanted to get back in front of the camera too. It's been a while, and like I said, I am working on a more formal, actual live coding stream around MCP for servers. Not sure exactly when that one will come out yet, but hoping sooner than later. So hopefully, maybe next weekend. I don't know, but hopefully I will see you again soon. And enjoy the rest of your weekend, and stay cool out there. My goodness, it's hot. Thank goodness I'm in my basement right now. All right, see you later.